mathematicians. My name is Alyssa Howell, and I'm the Secondary Director for Mathematics in Houston ISD. Today we're going to use the information that you learned about integers and solving equations with cups and counters in a whole new way, because today we're going to be solving equations with rational numbers, and that's about fractions. So let's pretend that I gave you an equation that said 1/2 x is equal to 3. If you remember, we were using cups to represent our variables, like 1/2 x, 1/2, I'm gonna have half a cup? That does not make any sense. And that's why we need to use our new tools for today. So let's get started. As we mentioned today, we're gonna be using a new tool. We're gonna be using strips or bars of pieces of paper. If you notice, I have just strips that I've made using my ruler, and I just traced my ruler on a sheet of paper, and that's how I made my bars. So you just need to take a moment to make several bars or several strips so that we can use them to solve our equations. The rule of thumb is when we're using strip diagrams or bar diagrams that we need to make sure that we set the problems up with equal sides, because we're studying equations. And we'll get into that more in just a second. So the first equation that I would like for us to look at is x plus 5 equals 8. Now remember, from our definition of an equation, it has an expression on one side equal to an expression on the other side. There are two expressions that have the same value. They're equivalent to each other. They're equal. In this expression, I see that I have two terms. Do you remember what the x term is called? Let me let you think about that for 3 seconds. That's right. The x is called our variable. Our 5 is called the constant value. So x plus 5 has two terms in this expression with a variable and a constant. When I go to the other side of my equation, it just has one term. It has a constant term of 8. And this is our equation. So we want to take two bars or two strips, and I'm going to put x plus 5 on one of the strips, and I'm going to put 8 on the other strip. So let me let you get two strips very quickly. All right. So I have my two strips, x plus 5 and 8. Notice how the two strips are equal to each other, because this maintains our equivalency. And we have to be very careful that everything that we do will maintain that equivalency. Now let's talk about what these mean for just a second. What does x plus 5 mean? And what does 8 mean? Let me let you think about that for a second. Do you know that the 8 means that it's 8 units long? 1, 2, 3, 4, 5, 6, 7, 8. I bet you knew that. So if I know that 8 means there's 8 units added together all in one piece, one constant term, what do you think that x plus 5 might look like? That's right. We definitely have 5 numbers, 5 units, and then we have a variable term for the x that we don't know how much it equals. And so this is our strip diagram. Sometimes people like to move these out of the way so that they can still see the x plus 5 and the 8. I like to move them up just a little bit so I don't forget what they are. And I have my x plus 5 and I have my 8. Now when I line these up, I want you to notice something. Do you see that these units add up? And that these, they don't add, they match. And that these match. And that these match. And that these match. So I have 5 of my units in this expression match 5 of my units in this expression down here. So really, these pieces of the bar are exactly equal. And what I'm left over with is X and 3 markers, or 3 units. So X is equal to 3. So let's think about this another way, because this is how a bar diagram can work, but it can also use some information that we learned in our first 3 sessions about 0 pairs. If I have X plus 5, do you know what a 0 pair would be for the X plus 5? Do you remember what a 0 pair is? If I look at my positive 5, my 0 pair for positive 5 is going to be negative 5. So if I add a negative 5, I can cover up these 5 little units. And if I'm able to add negative 5 to that bar, guess what I need to do to my bottom bar to maintain the equivalency? I have to also add a negative 5. So I take 5 more. And you'll notice what I have after that. When I have a positive 5 and a negative 5, that's a 0 pair. What happens when I have 8 plus a negative 5? How much is left over? Well, I can see, I'm going to shift my bars down just a smidge. I can see that on my top bar, I just have X, and in my bottom bar, I have 3. And that's how we can use strip diagrams to solve an equation. Let's try another one. Okay, let me let you clear your boards. Get 2 more strips ready as I'm getting the next problem. So get 2 more strips ready. And this time I'm going to have you make the strips for 3x on one bar and 12 on the next bar. All right, do you have those bars ready to go? Here I have my 3x, and now I have my 12. Oh, this one's a little bit harder because I don't have anything added or subtracted. I really like those with the adding and subtracting because then I can do my 0 pairs. I like doing 0 pairs. This is gonna make me think more. So if I have 3x equals 12, I can rephrase the 3x. What does that mean? Oh, that's right. This means 3 groups of x. So I have 3 groups of x's, or 3 x's. So what I like to do is I like to take my strip, because it's telling me I got 3 of them, and I'm gonna fold this so that I've got 3 right on top of each other. And when I open it out, I have 3 sections, 3 equal sections, because that's what's telling me. This is 3x. It means I've got 3 groups of x. And that helps me to draw that on my strip diagram. So if it helps you, we can have one big 3x, or we can break it into its 3 pieces. We can divide it up. Now, if I do that to the 3x, shouldn't I do that to the 12 also? So I have a full 12 units, and I need to divide it into 3 pieces, because tell me I need 3 groups. So I take my 12 and I fold it up so that it makes 3 equal pieces. See all that? Fold up my 12 into 3 equal pieces. And if I have 12, do you know how much 12 divided into 3 equal pieces might be? That's right. It's 4 in each piece because 12 divided by 3 is 4. So if that's the case, how much does 1x equal? 1x equals 4. So let's write that down up here. Let's write down our thinking. The way we thought through this problem was that I knew that I had 3 groups of x equals to 12. And I had to fold my strip into thirds. So I had to divide it by 3. And if I divide this expression by 3, I need to divide my 12 by 3. And when I do that, I got x is equal to 4. So how are you feeling about this? Are you feeling okay? All right, let's amp it up a little bit more and let's make the problems a little more difficult. And then I'm really gonna lay it on, really give you a hard problem. Let's look at 2y plus 6 is equal to 12. Now notice how we're getting a little more difficult here. Let me give you just about 4 seconds to see if you can notice what is different about this equations compared to the ones we were doing. What's different about this equation compared to the ones that we were doing? So I'll give you 4 seconds to think about that. All right. Did you notice that in this type of problem, I have everything that I was doing combined all in one problem? I have some addition going on. That was like the first problem. I have some multiplication going on. That was like the second problem. But it's now all in one problem. So we really got to put our thinking hats on now. So how many bars do you need? Good job. We need 2. We need 1 bar for the 2y plus 6 expression, and I need another bar for the 12. So let me get my bars. Okay. And I really, I'm going to give you just a second to think back to when we did our first example with the strip diagrams. What does this really mean? If I have a 12 down here, do you remember what this meant? That's right. There were 12 units that were all divided up into there. What does it mean when I have 2y plus 6? I have 6 units, and then I have 2 y's. So some people like to leave it like this. Some people like to mark off the 6 units and then the 2 y's. So let me show you. If I do that, it looks like this. Some people like to think about it like that. It helps them understand it a little bit better. So the first thing that I do, yes, you're exactly right. The first thing that I do is my 0 pairs. So if I have a positive 6, what is the 0 pair for positive 6? That's right. We want to do negative 6. So I put 6. All right. So what is our first step? You're right. We want to try to use our 0 pairs. So as I look at 2y plus 6, I want to focus in on the plus 6 and see if I can think about how I could form a 0 pair with the positive 6 or the plus 6. Perfect. You're thinking perfectly. All right, we're going to throw in our negative 6, because if I can add in a negative 6, ooh, my manipulatives are not being straight. If I add a negative 6, then that takes care of all of my units, and I'm left with 2y. Now remember, if I add a -6 to this particular expression, to this side of the equation, then I have to also add -6 to my other expression or my other bar. And if I add a -6 to the 12, then that's going to leave me with how much? Do you know how much 12 plus a -6 is? That's going to leave me with 6. I'm going to have 6 remaining. So let's kind of write this down so we can track ourselves. Right now we have a 2y plus 6. We added a -6 to form a 0 pair. We added a -6 to the other expression so that we could maintain equality. I have my 2y, and then I have 12 plus a -6, and that's just 6. So that's what we've done so far. So I think it's a little bit easier if I create a new set of bars. So let me just push this out of the way just a little bit. And that left me, if you remember, I had 2y is equal to 6. So if I have 2y is equal to 6, how am I going to find out what 1y is? Oh, well, this was like our second example. If I have 2y, I can divide it into 2 pieces. And if I fold it into 2 pieces, that gives me a y and a y. That's my 2y. So I divide it in half. And the same thing happens with the 6, because if I divide this side by half, I need to divide this side by half. So if I fold it in half, I end up with a 3 and a 3. So let's write down our thinking. What we did was we divided by 2, divided by 2 so that we could get a half. And that left me with 1y is equal to 3. And so we'll write that down. Y is equal to 3. All right, so each of these equations are going to step it up a notch. We're going to make it a little more difficult each time. So get your next 2 strips ready while I pull all of these off to the side. We're done with these. So for our next problem that we're going to do, we're going to start investigating how to solve equations with rational numbers. Now remember, rational numbers are often written as fractions, as we can see in this example. I have x divided by 2. Another way, or in other words, x over 2 or x divided by 2, is it's easy to think about this as, with an invisible 1 half x. That's another way to rewrite x over 2. And in this situation, this is one of our bars. X over 2, or 1/2 x, is equal to 3. So let's talk about what this means, the 1/2 x, or the x over 2. If you remember from elementary school, if they gave you an image like this, and they told you that they wanted you to shade in half the figure, you would take the bar, cut it in half, and shade in one of the 2 pieces. That's what a fraction does, 1 out of 2. So when I look at my equation, this is what's representing 1 out of 2 x's. This is half of the variable is equal to 3. So if half of the variable is equal to 3, if I double this, or multiply it by 2, then I can double this one and multiply it by 2. And let's look to see what happens. If I have x over 2 and an x over 2, that's 1 whole x. That's 1x. But if I do that to one side of the equation, if I multiply it by 2, then I have to do the same thing to the other side of the equation. And so I have to have another 3. So what I did was I multiplied by 2. I multiplied by 2. And that left me with 1x, because this is all 1x, 1/2 plus 1/2, is equal to 6. So 1x is equal to 6. So this is how we're going to start doing fractions with our strip diagrams. And this is kind of confusing. It's really hard. Stretching your brains now, stretching it really, really into those higher levels. So let's try this one. I have 2/3 x is equal to 8. So again, how many bars do I need? That's correct. I need 2 bars. So do you have your 2 bars ready to go? I have my 2/3 and I have my 8. Now this one's a little bit harder because I'm talking about 2/3. So again, let's think back to when we were in elementary school. 2/3 means I have taken a bar, I've divided it into 3 equal sections, and I've shaded in 2 of the 3 pieces. So 2/3 x. So this is 2 pieces out of a possible 3. 2 pieces, okay. I know what I can do. If I fold this in half, I like to fold. If I can fold this in half exactly equal, if I fold it in half exactly equal, what I end up with is 1/3 and 1/3. Because that is equal to 2/3. That's like my 2 pieces up here. So I have to do the same thing to my other expression. I have 8, and I'm going to fold it in half. So I fold it in half. And when I fold 8 in half, what I find is I have 4 and 4. So notice that the first thing that I did was I divided each of my 2/3 x in half, and I divided my 8 in half. But this only gets me 2/3, and remember, I want the whole thing. I need to have 3 whole pieces. So really, I need another piece here. It's not enough to know how much 1/3 of an x is. I have to know how much 3/3 of an x, because remember 3/3 x is 1 whole x. Do I know how much that little piece is? If this 1/3 x is 4, and this 1/3 x is 4, guess how much this 1/3 x? It's 4 also. So 3 of the 1/3 pieces, 1/3, 2/3, 3/3. That gives me 1x, and it's equal to 4 plus 4 plus another 4. And that's 12. So let's talk about our thinking again. What was the first thing we did? We started out with 2/3 and 8, and then we divided it in half. Put that 2 right there. And what that gave me was it gave me pieces of 1/3 and 4. Gotta get it going the right way. So I have 1/3 x is equal to 4. But I didn't need to know just 1/3. I needed to know how many 3 of them were. So that's why I multiplied by 3. And that gave me 1x is equal to 12. All right, so I've made it harder, but this is our last problem. And this is the absolute hardest one I can give you like this. Because, do you see this? It has the addition and the subtraction. It has addition. It has the multiplication going on, but it has a fraction and it has a negative number. So it's like I've thrown in, this is all 4 videos all in one. So we can solve this using strip diagrams. I know we can. All right, are you ready? Okay, so we always start 2 strips. And we're gonna put one expression on one strip, and we'll put the other expression on the other strip. So let's get that going. one strip needs to say 2/3 x plus 1. And the other strip, excellent, that's right. It needs to say -5. So we're gonna think through this like we always do. What do these mean? Okay. Well, I'm gonna start with the one I know better. This one, whew, that's a lot of thinking. Let's start down here, then -5. Do you know what -5 means for this constant term? Yes, that's right. It means that there's 5 little units in here, that each of these units is a -1. And that helps me out. Ooh, because this makes me think. Do you see this positive one up here? I need to have him zero out. So do you remember what we used when we want to zero something out? That's right, a zero pair. So I can add a -1 to that expression. Excellent, you are on it now. That means I also have to add a -1 to the other expression so that we're doing that to both sides equally. So that means I added a -1 so that I could get a zero pair, and I added a -1. While this made a zero pair for this expression, this top expression, and it just leaves me with 2/3, let me write that down before I forget. It doesn't form a zero pair on the other expression. A -5 plus a -1 doesn't form a zero pair. Do you know how much -5 plus -1 is? Yes, excellent. It's -6. So I think it's a little bit easier. I'm gonna recreate the bars so that I can think through it a little bit better. So it's always good. I still got 2 bars, but this one says 2/3 x, because remember, got rid of the 1. And this one says -6. So I'm thinking through this one. Oh, this is just like the last problem. Thinking back to elementary school, 2/3 meant that 2 pieces out of a possible 3 were shaded. That's 2 pieces out of a possible 3. I know what to do. I know what to do. Do you know what to do? We're gonna fold this one in half. So we're gonna cut it in half. We're gonna divide by 2. So we divide by 2. And when I fold these in half, I divide it by 2, divide it by 2. Uh-oh, I have them written on another one. I'm right here. That is the 2/3 divided in half. And what do I get when I divide -6 in half? You're right, I get -3 and -3. All right, so we're almost there. So we've rewritten this so that when I divide by 2, I get 1/3 x. And how much is each of the 1/3 x's equal to? -3. But I'm not done because I don't care how much 1/3 x is. I want to know if this part is -3 and this part is -3. Watch this. I need to know what a whole is. 1 whole. So I need a total of 3 pieces. So I have to multiply by 3. And I multiply by 3. So that when I get to my final answer, -3, -3, this last piece will also be -3. So that the final answer is 1 full x is equal to -9. Excellent. You've done a great job so far. That was a lot of work and a lot of thinking. I'm very proud of you. So if you need more information or you're still looking for more practice on using strip diagrams, Please remember that you can find these resources in our master courses at the grade 6, grade 7, and grade 8 level. Thank you for joining us. Again, my name is Alyssa Howell for HISD. Thank you.